Up next, we have Mohammad Mehrab Alam. Mehrab's interest is in big data space, and he's been working on ingestion system and FStream, which is our internal streaming framework, which internally uses open source tech stacks like Apache Kafka, Apache Spark, Flink, HDFS, etc. He is here to talk to us about Un-skew it, production taming of Kafka. Over to you, Mehrab.
Hello everyone, my name is Mohammad Mehrab Alam. I am working as a software developer in Flipkart. In this session, I will talk about how we solve the partition and partition leader skewness problem to get consistent performance from the large Kafka cluster. So as an overview, uh, we will see what Kafka is, what the scale of Kafka in Flipkart, what problem we faced and how we debug that problem, and finally how we solve the skewness problem. So Kafka is a distributed data store which is optimized for high ingestion throughput, process streaming data in a real-time fashion. A Kafka cluster has multiple brokers, and that broker may distribute in a different racks. And a topic partition, which actually stores the data, resides on the broker, and depending on the replication factor, its replica will be replicated in the Kafka cluster. So if we represent the if we generate the partition plan for a topic A, it will look like this. So in Flipkart, we ingest more than 60 billion of messages per day, and that is you can say more than 30 terabyte of data per day, and we consume more than 2.5x of what we ingest. So the data ingested in Kafka cluster is actually consumed by different pipelines, and that pipelines is actually started facing you can say consumer lag issues, and that was due to the uneven consumer pole latencies from the partition, and consumer throttle time increased significantly from few milliseconds to minutes. Produce time also increased. So during our debugging, we explored the broker, Kafka broker, producer, and consumer matrices. What's the existing distribution of partitions across the broker? Also explored the server matrices and what maintenance operation we performed on the Kafka. So what we found that this problem started after actually adding the new brokers as a part of a scaling up activity. And after adding new brokers, we ran the reassignment of partitions to make Kafka cluster balance. And because of this, we saw skewness in the number of partitions, you can say in a broker within a rack. And this is especially for the topic which has, you can say, large number of partitions. And because of uneven use of broker, this leads to latencies and throttle issues. So to solve this problem, we took the motivation from the rack awareness property in Kafka. If Kafka cluster is rack aware, it means the partition replica will be replicated across the racks. So let's say Kafka cluster is rack aware, and if any rack goes down, then it will still work. Right. So basically, this rack awareness provide the fault tolerance. So if we use this property and within a rack, if we move the partitions, you can say across the brokers, then it will not impact the fault tolerance. So we use this property to devise an algorithm to unskew the partitions within the same rack for a topic at a time. So just take an example. We have a topic A. Total number of partition in topic A is 10, and you can say that partitions is distributed in a 5 different racks. So for this example, I am taking the distribution in the rack 2. So which is something like this. So the total you can say which is leader plus follower count is something like this. So we convert this into the array of tuples. The first element of tuple will represent the broker. Second will the leader plus follower count. Now we will calculate what will be the ideal count of partition per broker in the rack. So that will be the ceiling of total leader plus follower. divided by the total number of broker on which the topic partitions present. So in this case, it will be 3. So now we have an array of tuple. So left side of array has more number of, you can say broker. Left side of array has broker which has more number of partitions, and the right side has a broker which has less number of partitions. We will search for partition whose replica has broker 4 but not 3. So we found a partition 0 replica has broker 4 but not 3. We will replace broker 4 with broker 3, and we'll update the topic A partition plan also. Then we'll update the count in the array. So now broker 4 has total 4 leader plus follower, and now broker 3 has 2. We will repeat this process until the count will be less than equal to 3. So this was the earlier one. After running this algorithm on this distribution, it will look like this. So now broker 4 has only 3. Now broker 3 has you can say 3 leader plus follower count. We still saw the similar problem, but severity was less. So further debugging, we found that some of the brokers still have, you can say some of the broker has more number of leaders as compared to others, which actually creating this problem. So from the above example, if you see right, the broker 3 has 2 leaders, but broker 2 has 0 leaders. So somewhat if we move, you can say a leader from broker 3 to broker 2 will balance the leaders in the brokers for that topic. So, so the approach is almost similar to what we did earlier. So we will use the earlier, I can say, generated plans as an input for this, you can say, algorithm. And for every topic in the rack, we swap leaders from the broker, which has more leaders, and the non-leader from the broker, which has few leaders. So after applying this algorithm, so this is the earlier one. Now one leader will switch from broker, you can say 3 to 2. So it will something like this. So now every broker has, you can say almost equal number of leaders for that topic, and the total number of leader plus follower count is almost equally distributed. So as a summary, if you want to, if you basically get the consistent performance from the Kafka cluster, your Kafka cluster should be balanced in terms of data in the partitions. We uses Kafka tools to manage our Kafka clusters, right? And all the above algorithm as added as a balance, you can say balance module in the Kafka tool 4. So what's next? So the plan generated currently is not well optimized. So the movement of data is, you can say, can be reduced. So we will try to optimize the plan. So effectively, this will reduce the reassignment operation cost, or you can say time. Yeah, thank you.